This is Physics 2212, Lab 1 with Charged Tapes by Jackson Greenquorum. For a quick little introduction, using Coulomb's law, which is finding the electric force through the distance that we held the tapes together, Newton's second law, where the force of gravity is equal to mass times acceleration, and the free body diagrams, we can make a computational model of these tapes that we are electrically charging and then holding close together to see what the effect is. And by creating different models, students can determine what the differences are in an idealized world versus the real world where other factors come into play. And again, so the purpose is to identify and calculate the electric force and the gravitational force in equilibrium to see which one affects the tapes more. And for our main ideas, we're going to be describing and illustrating what happens when two charged pieces of material come into contact with one another's electric field. And we're going to show the differences in the force of gravity and the electric force. So for my computational model, I have this little bit of code where I have my constants right here, charge of the proton, gravitational constant, tape mass, separation distance, which we found through our experiment. And through our experiment, we also found that our pieces of tape had 2 × 10 total atoms. I have my system and surrounding defined here, my force of gravity and my electric force right there. And now we are going to see the outcomes. So the outcome of this is that the gravitational force on the tape is this number. There are 1.11244 e to the positive 11 deficient electrons on the tape, and that there's a ratio of 5.56218 electrons per piece of tape, which is per atom. And so the models I used in this code and throughout the experiment were the free body diagrams, F equals ma, and Coulomb's law, which is the electric force equals K Q1 Q2 R magnitude squared, all of that times r hat, which is the direction unit vector. And the differences that we saw from this experiment was that the number of atoms from the experiment was 2 e to the 10, and that our ratio was actually 14.5. From our code, the number of atoms was preset, but we found that our ratio was 5.56. So the possible sources of error come from human error, which we'll get into in a little bit, but it's something called grounding, and mishandling the tape. So for our what if questions, what if electrons had positive charge and protons had negative charge? What would change about the observations I made with my tapes and any other charged objects? Well, in reality, nothing. Because you got to think, our two pieces of tape during our experiment we found were negatively charged. When you bring two likes together, we all know this, it repels. Well, if those two negatives became two positives, they would also repel. So nothing really would change. But why is it important to handle the charged tapes as little as possible? Well, like I said, it's something called grounding. We grounded the tape, meaning we took its electrical charge away, and therefore it did little to nothing to our other electrically charged tape. So that was our group's main source of error when concluding this lab experiment. But in an idealized world, that tape was held at a certain distance, which we did find initially as 0.0381 meters. But after handling the tape so much, trying to recreate it, nothing happened. But yeah. In conclusion, we found that the electric force is much stronger than the gravitational force. Free body diagram shows that until the electric field becomes in contact with the other object, that the object will stay in equilibrium until the other tape was moved close enough to actually move it. Anyways, this has been Lab 1 with Jackson Greenquorum. I hope you enjoyed.